Alright, so we have a test on transformations coming up. You can get it signed by your parent to get those points. You need to make sure that you turn it in signed on the day of the test, not the day after. So if we look at this first one, we're talking about similar triangles. We need to prove proportionally why they are similar. I'm a very visual person, so I actually do this with colors. Remember when they list the labels of the triangle, AB is first and DE is first, that means side AB is similar to side DE. AB or BC is second and EF is second. So EF is similar to BC. And then lastly, we have CA and FD. So AC and DF are similar. So my personal preference, because sometimes this gets a little overwhelming looking at all of these different letters, is I'll go through and I'll color code. Here's AB, AB and DE, and wherever I see that, then I'll mark it. And then I have BC and EF. Sometimes I miss some. And then I have DF and I have AC. Sometimes they write them in a different order. They write them backwards, but remember, it doesn't matter. The order is still the same thing. So if I look at this, when we talked about proportions and solving proportions, you can have similar sides or the congruent, not congruent, similar sides, the sides that match up going across, or you can have them going up and down. We never, ever, ever have similar sides going diagonal. So if I look at this, similar sides are diagonal, not this one. Diagonal, not this one. Here, these are across and so are these. These are up and down, but these don't match. So we can't choose that one. So it has to be C. Okay? So just a visual, colorful way for you to see what's going on. So we can do the same thing on this QR, which is first, and LM, which is first. We have RS and MN. So all I'm doing is I'm looking at these letters just like I did previously, ST and NO, and then QT or TQ, same thing, and LO or OL. So notice this one says which one is not true. So if we look at this, I can say, okay, ST, which was yellow, and LO is green. So these do not correspond. They are not in the same spot. So this one is definitely false. Angle N, which is here, and angle S. So you can look at your letters with that also. We can call this RST is another way for angle S. And we can call this MNO for angle N because your letter is in the middle, which is at your vertex. So if we look at that, we can see, and we can even look up here, RST, MNO. So they're in the same spot. So angle N is equal to the measure of angle S, because this word proportional, you have to be real careful. Same shape, yes. They are the same angles. They are different sizes. But, so it meets the whole definition of proportional. However, angles are not proportional. Angles are congruent. So if this said congruent, then it would be true. But because it says proportional, it is false. Okay? Angles are never, never proportional. Angles are always congruent. ON and TS and QR and LM, so we can see that that proportion is true. And RQ and ML, those line segments are proportional to each other because these are going to be different measurements based on this word similar up here. So this is true. So there were actually two answers on this one. There was a missing number on the number 3. Sorry about that. There should have been a 20 down here because you were probably like, where's the 20? So what factor do we multiply 20 by in order to find x? So we're going this way. It is getting smaller. So that means that our scale factor is between 0 and 1. So based on just that information, I can get rid of letter C. We've talked about how to make a proportion for this. And when we're making our proportion, we can match up our sides. If you wanted to use colors for this, you could. So I have 10 over x is equal to 40 over 20, because again, these are on the same shape and so are these, and these are corresponding sides. So the scale factor, remember factor is multiply or divide. We're going this way. So 40 goes into 10, we would be dividing by 4. So you would have to take the 20 and divide by 4. But notice there is no divide by 4, because when we're doing scale factor, it's only multiplying. So when we're dividing by 4, the other way to write that is to multiply by 1/4. Number 4, we have vertices, and it is the polygon is dilated using the center as the origin. The new coordinates are 10, -4. So here I can write my original coordinates 5, 2, and they're going to go down to 10, -4. So I'm saying, what am I multiplying here to get these coordinates? Well, 5 times 2 is 10, and -2 times 2 is 4. So this is my scale factor. And it is getting bigger, so it's going to be A, because 1, it's getting bigger, which is an enlargement, and 2, this is the one that shows you times 2. On the back, we could do the colors again. But I want to talk to you about these angle measures and these little lines. So this has key angle P has one line, and so you can see that it is in fact equal to angle Z because it also has one line. You can also look at it is the last letter, and it is the last letter. So I would start off with writing my equal statements. Remember, if they're similar, then these angles are equal. So angle P is equal to angle Z. So I'm just going to look for that down here because there's a lot going on. So let's eliminate some stuff so we're not looking at so many things. P and Z, very nice. P and W, no. P and Z, yes. P and Z. So then let's look at this one with the 2. So we have the measure of angle O is going to be equal. Which other one has 2? Angle Y. And also O and Y are third in our list. So now I can say O and X, no. O and Y, yes. O and Y, yes. O and Y. So then I can look at my next one. Angle N has 3 and angle X has 3. N and Y, no, well we already eliminated those, so we don't actually have to look at those. N and X, and then this says M and W and M and W. So at that point, we're going to have to go over here. So just because I'm visual, MN and YX, so I can say MN, Y, so those match. Not a big deal. Try another one. X and Y and N and O, N and O. N and O, X and Y. Okay, right here. This one should be matching if they were correct. So then we can eliminate C, and it is D. This is what we were practicing the other day with slope and similar triangles. 2 right triangles are graphed. Write your slope proportion to prove your answer. So you needed to write down your coordinates. Remember, we don't need these vertices where the right angles are. This is 8 and 6, and then we also have 12 and 8. So we can go x1, y1, x2, y2, x1, y1. And if I'm going to set this up, I can say 6 minus 2. Remember, this formula is on your chart, and you will have a chart. 8 minus 3 should be equal to, over here, 6 minus 8, and then 8 minus 12. So I get 4 over 5, and over here I get 6 minus 8 is a negative 2 over negative 4. Hold on just a minute, something went wrong. All right, that is not right because I miscounted. This is 9, 6. So let me change that. Got to make sure you have your right coordinates, otherwise it doesn't work. Try again. So x2 is a 9. And, oh, this was still an 8. I erased the wrong one. This is a 9. All right, try again. 4 over 6, that looks better. And negative 2 over negative 3. Well, I know that 4 over 6 can be reduced by 2, and we get 2/3, and a negative divided by a negative is a positive. So we can go back to our statements here. True. Hypotenuse of both triangles have the same slope. Well, was this the hypotenuse? Okay, so that's a possibility. The slope is less. Oh, there's supposed to be a number there, but it's not true because the slopes are equal. The slopes of the hypotenuse cannot be determined. No. They have the same slope. That's all there is to it. RST is translated 2 to the right and 2 down. Write the algebraic rule. We spent a lot of time writing the rule. Remember, to the right is a positive on the x, and down is a negative on the y. So, congruence and orientation. So remember, congruence means that it looks the same, meaning the vertex or the vertices, which is plural of vertex, are in the same places, right? So when you translate, that is going to be congruent. And when you dilate, because it doesn't change that order, it just shrinks it. Orientation is how it looks. Okay, orientation means that it didn't get turned. I'm sorry, congruence. I did these backwards. I'm having a day. Orientation. This is the definition for orientation. Congruence is they are equal. So translation, go back, reflection, and a rotation. I did it backwards. Orientation is a translation and a dilation. I apologize. It's been a rough day. So orientation, it looks the same. Congruence means that they're equal. They did not grow. They did not shrink. All right, let's see if I can do better on this page. Complete the grid with the degree rotations from the rules. So you're going to have some questions where you have to know your rotation rules. So remember, we always count counterclockwise. So this is going to be 90 counterclockwise, 180 counterclockwise, 270 counterclockwise. If you want it, and this would be 360. If you wanted to go the other way, you could say that this is 90 clockwise. This is still 180. And this would be 270. So we talked about our rules. I'm going to do some pen because I'm going to write on the grid. So we said you start with XY, and then you flip it. So now it's YX. And then you flip it again, XY. And then you flip it again, so now it's YX. And then you go back and you put the sign from the quadrants. So quadrant 1 is positive, positive. Quadrant 2 is negative, positive. Quadrant 3 is negative, negative. And quadrant 4 is positive, negative. So you need to make sure you know how to apply those rules. Reflect the image across the x-axis and write the rule. So I'm going to highlight my x-axis because, again, that just helps me see. Remember when we did reflections, if you can count, you can do it. So we are just going to count how far away each of these are. 1, 2. So I'm going to go down 1, 2. 1, 2, down 1, 2, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Here's my picture. I didn't put any letters on here, but as long as you have the coordinates and you can write the rule, you're okay. So I'll just start here. This was at 2, 1. This is at 5, 1. This is at 2, 5. And now I'm at negative 2, 1. negative 5, 1, and negative, oh, I did that backwards. No, I did that right. Negative, I did 1s and instead of 2s, didn't I? It is a rough day for Mrs. Ray. There we go. 2, and then 5. Oh my goodness. I'm not doing any much better on this page. 5, 2, negative 2, 5, negative 2. There we go. 2, negative 5. Whew. Rough day. So my rule is going to be x, y, and I can see that my x's stayed and my y's changed. Remember what we talked about? If you're going across the x-axis, the y is going to change sign, and if you're going across the y-axis, the x is going to change sign.